Understood, man? Okay, it's recording. Okay. But it still is going ahead, acting like this. I don't know. I'm going to share. Okay. Hopefully, it's not a problem. So, I will select a specific. I'll select a specific one. But now, after the net. So this is what I was saying, right? So this is your data matrix. This data matrix refers to what? Rows are observations, right? Columns are variables. This is V1, this is V2, like this, right? Let's say this is V100 and 1000 or 300, can be, right? And this is observation 1, observation 2, that means experimental units or individuals, like that, right? So observation can be, should it be exactly like this? Huh? Doesn't have to be. Yes, doesn't have to be. Talk loudly. Even in your job, you have to talk loud. There is no hierarchy in real life. Okay? Only you are the most important person in the world. Everybody, I'm telling you. What do you feel you just say? Okay. Sometimes you have to say that. So saying, hey, I can't understand what are you talking. You have to say that. Be bold, because it's your life. Enjoy your life. Fuck. That's the only thing that connects life. Right? If you don't know, if you don't talk to them, they will think, oh yeah, you're a nice person, they'll walk over you. Is that what you want? No. So can it be how many here? Yeah. It can be anything. And it's fine. It can be. So can I put 100,000 maybe? 100,000 records. 1,300. Can it be here 100,000 variables? Of course, yes. Right. Can it be more variables than observations? Yes. Can. Right. But usually we don't want to have too much independence here, right? Because even if you have 10 variables, it's hard to imagine, hard to solve the problem. Why you want to collect too many things, right? But the point is, this is a matrix data matrix. Can we call this as the 100,000, right? That is rows, 1,300, right? What we are saying is that this matrix can be rewritten as D1, D2 plus D2, D3, like this. And what is that I can write into? D? Can it be D100,000? It cannot, right? Good. Everybody understands? Everybody agrees, right? It's a minimum of rows and columns. Minimum of rows, and that's how you got it, right? Okay. So it can only be 1,000, right? And the question, what we are saying is that now, how do we get this D1, D2, D3? That is what your decomposition formula. That is the general decomposition formula called singular value decomposition, right? But this is decomposing data matrix. And I'm still we still have PCA and FA. That is, PCA means principal component analysis, FA means factor analysis, right? So when we do principal component analysis, we are not directly working with the data matrix. From data matrix, we get something and then we work on that. What is that? Variance covariance matrix. Everybody agrees, right? So PCA is about understanding the spread of the data and what dimensions explains the most of the spread of the data, correct? PCA is about, so data matrix, from data matrix. So any given data matrix, I can create a variance covariance matrix, right? So we'll call it as variance covariance matrix V. So what is this V size? So what is the size for this example? 1,300. Everybody gets it, right? Yeah, why nobody else is talking other than us? I'm just repeating it for you. Talk, man, just please. I won't ask this question after 3 months because I won't be talking to you. This is the only time I interact with you. You know, you're my friend, right? Okay, I am your friend, right? You also are not. Okay, 1,300. So, you know, you cannot make mistakes, I tell you. You can never make mistakes with anybody, You know, if your heart is pure, it's clean, you're only talking, you know, hey, you know, this is what we are supposed to do. This is the conclusion. Why it's happening, why it doesn't happen. That's the end of the story. So, this is 1,300. This is the variance coefficient. Do you know how to calculate each of the variance coefficient elements? What does this mean? This means like this is, first of all, there is a very special property about variance coefficient. Anybody wants to say that? Arun. 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 Ven Kumar. You know how to calculate each of the elements. If I give you a data matrix, can you calculate that? Of course, you don't have to do manually. I will do for you, but you have to know what it is. What is that? Anybody? Anybody now? Jeffrey. She's the only one she's talking to. Soumya. No? Everybody calculate that. Rajesh. Variance, do you know how to calculate variance? Please, you have to know that. It's a simple interview question. You know how to do variance, right? Huh? So you take this, it's about variable by variable, right? So you take this first column and then do with that column data only. That is variance of V1. Correct? If I do with V1 to V2, that is a covariance of V1 and V2. All right. Anybody wants to say the formula? You'll get a star. For variance. You say it with respect to V. You know it only with X. Okay. So this I will notate it as V11, V12, right? Can I do that way? V1300. V1 comma 1300, right? Correct. Everybody? And then V21, V22, like this. V2 comma 1300. Here V1300. You are able to understand these numbers, right? I'm not writing clean. Is it okay? No comma. Huh? This is V1300, comma 1300, right? This is your variance coefficient. What is the relationship between this and this? They are the same. Variance of the covariance of V1 and V2 is same as covariance of V2 and V1. Okay, symmetric. That's why it's called symmetric matrix, right? So nobody said that, so I will write the formula here. It comes from the D. We'll call it this as we don't want to call it as V, but to use it in O notation. Yeah? So the V11, right? Summation of O1J minus O1J minus V1 bar. Correct? Vinish, Avinish. Yes. V1 bar. Yes. Does it look complicated for you? You know now you know, right? To finish this. Square this divided by what is the number? What's the number? Size. The size of V1 is what? How much? Size of V1. And that's the only alternative answer. I understand that. Or do you believe that it has to be 1,000? But I said the whole V1 is this, right? This is whole V1. So it has to be 1,000. This is V1. Our column is 1,000. So you know how to do this is 1,000. This is variance, right? This is 1 J. J varies from this J is 1 to 100,000. Correct? Everybody? But why did I put O1J? No, I don't need to O1J.
J from 1 to 1,300.
J, you know, this is the variance is calculated by variable by variable. Variance coefficient is calculated variable by variable. The variable is varying by the observation numbers, right? More complicated looking, but the fundamentals are the same. I didn't change anything, right? Xi is probably, you know, okay. If I put a Xij is your matrix, then This is, you want to do it this way, that's fine. X1J, this is X1. You want to call it as X1J, right? J means 1, 2, 3, 4, 5, 200,000. So I think maybe you want to do it this way, that's fine. But this is a special notation. X1 refers to this column. All right. Now, this is what, this is 1300 by 1000. So you are saying in a 1300 dimension world, what is that some method, mathematical abstract world, right? In that 1300 dimension world, you want to reduce it to 5 dimensions, 3 dimensions, because that is what humans can think and interpret. Even 3 dimensions is hard, right? 2 dimensions, consultants are very happy to do 2 dimensions, because it's easy to explain. So that is what your decomposition does. So what we are saying, not data matrix decomposition, which is singular value decomposition. Now I bring this to, let's call this a V1, please V2, like this, V1300. These are the reduced dimension. Maybe we'll call it as instead of V, we will call it as PC1 dimension, that is principal component. PC2 dimension, like that, right? PC 1300. But this we don't really like it, and it's useless guy. But still, because of the data, we calculate that. These are the most important thing. The first few are the most important. Okay. Each one is a principal component. Principal means main component, important. But the first ones are ranked by importance. That's how the mathematics is developed. So the mathematics is developed and computation is done for you to utilize that part. And you just do, you call for variance, you get variance covariance, you call for eigen. Then you get the eigenvalues and eigenvectors. Eigenvalues and eigenvectors are related to these, basically. So what we are saying is PC1 is how do we write the, how do we get the PC1 is actually against it? We get it now, so this is actually very nice. The way how we have come to this. I hope you will return this. I don't even have notes left. Okay. So so how do we get the PC1? Again, mathematics does it for you, or does it for you. Python does it, but don't worry. But you have to know how to interpret it. In the end, you are the master, not the computer, not the algorithm. Algorithm does what you want the algorithm to do. So the master has to be very clear. If the master is not good, there's a problem. Serious problem, right? So how do we calculate PC1? It says lambda 1 times some eigenvector times eigenvector transpose. Correct, everybody? That's what your first is learning. And what is this first eigenvalue? This is first eigenvalue. Right? Now you can get. I don't see. Okay. Okay. Anyway, this is the first eigenvalue. This is the first eigenvector, right? Correct, Arun? First eigenvector. How do you know it's first eigenvector? Your system gives you that. No worries. You just say eigen, the first eigenvector. We are going to see something, right? We can go back to places related to almanac. Eigen. Can you see? Read these letters. I read it small. That's good. First eigenvector, right? So that is the meaning of eigenvector. As far as we are concerned, that's what is helping us to identify the most important dimensions where most of the variance is explained. Our science, data science, the dominant part of that is statistical science, is all about where the data are located and how they are spread. That's what it is. Okay. So where the data is located, conditional means your regression models. Whether it is logistic or whether it is normal regressions. but we don't have outcome variable here. So where they are located is well, that's what the cluster analysis is. But this was right now, for some reason, the order is like this. The PCA is about how the data is spread in 1,300 dimensions. And in that, some dimensions are more important, some dimensions are less important. And very interestingly, it's not just the same variable dimension. They're rotated in a rotated world. We are going to find dimensions. New axis. And the new axis are the eigenvectors. Come. How are you? So that is what your first eigenvector is. Now, so remember again, I'm telling you, the first eigenvector is very involved, beautiful, mathematically sophisticated, computationally well established throughout the world. Humans believe in that, it's working, is your eigenvalue system. Okay, so it's done in such a way. Hundreds and thousands of PhDs were done, over the period of time, I'm saying. But it's all now well established. It pervades into all kinds of things, dynamical systems. Anything you take, eigensystems are there. It is a sophisticated way of transforming it into a new coordinate system, and within the coordinate system, which means it's a rotation. A coordinate system is the new coordinate system is basically rotating the old, E1, E2s are old. This E1 is not this eigenvalue. I'm not able. There's another one when we talk about 1 in nth place and so on. That is a different, maybe I should write it here. If you don't mind, if it is not confusing, I'll use a different word. This is your eigenvector, epsilon. All right. So, so you found out. Remember, PC1 is the first decomposed component of the whole 1,300 dimensions data into the most important dimension. This is the first most important dimension. Okay. So, what is epsilon 1 size? Can you think about it? Epsilon 1 is, again, has to be one, because we are talking about the eigenvalues are coming from this variance covariance matrix. It has to be sizes 1, because it is, let's say 1,300 rows, 1 column, right? And I transpose it here, that means it's 1 times 1,300, isn't it? So this is why this will become, if you multiply this, matrix multiplication, what is this one? This is 1,300, 1,300 matrix, you agree? So now I can remove all the things, and that's it. There's only one dimension in the whole data. It looks like it's 1,300. We captured 1,300 variables, but literally they're all lying in one axis, new axis. It's not on the same variable, but a combination of variables and one line, right? And that is your first dimension. And I can just remove, if rest of dimensions are not useful, I have reduced the whole 1,300 variable dimension data into only one dimension data. That's what this means, PC1. So when we say PC1, it is actually a matrix, reduced matrix, most important matrix, relevant matrix, which is representative of this, which is it's a spread of data. So I'm saying the whole spread of data is explained only in one dimension, which means it's all lying, the spread is lying on a line in a rotated space. So for everybody, right? Well, it's not one, but there are 2. You need to take 2. If it is 1, what does this mean? This means if the variance covariance matrix says we need one number to represent this as some value, right? We'll call that as what is called the trace. There is a terminology called trace. Okay, that's the one number, which is basically the sum of values of the lambdas. If lambda 2 is 0, lambda 3 is 0, everything is 0. That means 100% of the trace, the total variance. Trace is the total variance. I'm talking about one huge matrix. I'm combining it into one concept called trace. That means the total variance explained by one number, that is trace. Otherwise, it is a 1,300 by 300, right? So Rest of the lambda 2, lambda 3, lambda 1300 is all 0. Then this all matters to me, right? No, lambda 2 is not 0. Then okay, so then it is. This is what transpose is, remember, huh? So rest of them are all 0. But in real life, they are not 0. They are smaller numbers because of randomness and so on. It's not perfect 0. So, but there are statistical methods to determine, when to stop. Okay, so that is what is called the scree plot. I think I have talked about it. It's called scree plot, which tells you it goes down like this, and then so this is the scree plot is we are talking about the lambda values here. Okay, this is the largest lambda value, first one, right? 1, 2, like this 1300 values. If you plot it, the lambda values, it will stabilize. Afterwards, it is not really decreasing a lot. Right? That is the statistical thinking. What is meant by decreasing a lot? This is statistical thinking. It is stable, not stable. Okay. So, well, we have after 3 dimension, 4th dimension onwards, it doesn't change. So the whole data is really 4 dimensions, right? Not 3, not 2, 4 dimensions. And you can start. So we will talk about that. But this is how data to variance covariance matrix to explaining the spread in the data to matrix decomposition. In this case, it's called eigenvalue decomposition because it's a symmetric positive matrix. Okay, its variances are a positive value, right? So in a matrix context, we say positive definite. It's not called positive values. Variances are positive values, but covariance can be negative value. But in total, what does that mean? In a combined way, what does that mean? It's called a positive definite. If you want, you can write it down. That's fine. But the point is, we talked about from the data matrix, talked about variance covariance matrix, from variance covariance matrix, decomposition to when to stop, plot everything. This is what happens in PCA. Right? I kind of reviewed it. Any questions here?
So this is the trace that you say.
Trace is sum of all the eigenvalues. That's called trace.
The scree plot will tell us when should until which variable can I consider my PC1? Until PC4 should I consider this scree plot?
It tells you how many dimensions we need to explain the original variance covariance. See, we are explaining the original variance covariance. It tells you, it's basically when the lambdas are stable. That means, the lambdas are not going to change significantly the trace. Okay? And trace is the concept of basically definition of total variance explained. Right? So if 2 variables are, it is total variance means, it's a total the trace is, let us say 8 units, right? But 2 variables, explain 3 units, let's say. I'm just saying, right? 3 units. Lambda 1 plus lambda 2, 3 is 3. Lambda 1, lambda 2, lambda 3, lambda 4, lambda 10, lambda 1300 is 8. So can we say like 3 over 8? What does this mean? This means a percentage of variance explained by your first 2 dimensions in the rotated space. And I keep saying rotated. Does it make sense to you? What does the rotation mean? That means the spread is not really on the given axis, but it is in some other axis. So that's why, and that some other axis you can find out. And that axis, first axis this way, and very interestingly, this axis has to be, the second axis should be perpendicular to the first axis. All these things are beautifully part of the mathematics. It is assuring you, no, you don't have to worry about that. You don't have to struggle. How do I believe all this? Look, that's how it is constructed. There are a lot of beautiful things. It's already built into it for you. They are all decreasing. Lambda ones are decreasing. These are perpendicular axis in the rotated new space, right? Beautiful, right? You can't beat it. And you know when to stop, how many dimensions to use. These are the powerful principles that explains PCA. And that is done by basically a mathematical concept called eigenvalue decomposition. Okay, so let me put it to complete, right? This, right? lambda 1300, epsilon 1300, right? Epsilon 1300 t, that is transpose. So why do I do like this? This is the same vector, it's only a transpose. That is okay. Everybody's good on this one. So you know how to, now you know the full understanding of PCA. Huge dimensions of data, PCA, big data, and how to reduce it. All R does for you, but only your brain connects all these things. Otherwise, if I say, okay, this is the data, this is the first PCA, you won't really appreciate. I don't think you'll appreciate. I'm thinking you won't appreciate. I don't know. You have to tell me. Would you have enjoyed it? And I said, okay, here is the data, here is the code. If you do this, this is your first principal component. Now you know how to explain. Because if there is a contradiction here, if there is something that is not fitting well, you will ask the question. It doesn't matter who you are. I'm telling you today. A guy in a village will ask, sir, sir, he will say, mathematics is not coming together. That's what Tamil is. Kanaki sir, Kanaki is that. You know Tamil, right? Solongla. Right? That statement will, it doesn't matter. You don't have to go to IIT. If you understand these basics, foundation, your village guy will also answer. You can get high school student, you'll ask the question. How do you say it doesn't make sense? I started believing in you. Whatever you said, I believed. But you are saying something new, it doesn't fit in. That question, you have to be into that kind of place. That means you are given a collection of principles by which you can validate yourself. Nobody needs to convince. You can validate yourself, you will feel peaceful. That is where we want to take you there. That is the place of learning. Otherwise, if we just give you data, code, doesn't work. You have to be the master in your place, in your meeting. And that's why, we design this kind of, instructional methods, instructional approach, and we could do it also. It takes a lot of years of experience and stuff. These things don't come easy. Believe me, I can teach you very easily, but for me, it took years to figure out nicely these pathways. Okay, so and we have to do. Every one of you have to go in that pathway. So I kind of maybe you might feel that I'm pushing you. Yeah, well. This guy doesn't have any other work to do. He's talking about all these things, big mathematics. Just give me a job. You can all these things, you will get it. Because in the interview, you will be the master, not the other guy. And we want to get you there. Every one of you. Every one of you are capable. Provided you talk. Right? You're ready? You will talk, right? I want you to come out, this is your place. I always say, she knows that too. 3 months from now, 2 months from now, after I'm finished ML, I won't even talk to you with the same passion. Because you are a graduated guy, sir, everything, you know what I said, right? What's sir, how are you doing, right? We talk at that level, and you are an accomplished person, you know whatever you need to know, you do your work, but this passionate communication won't happen. Huh?
The same level we can talk in the same place.
We can talk, that is fine. But what I'm saying is, in this push, I will not make that. Right? This is the place, time. And I hope you grab that. Because there are some deep insights here which you will never get any other way. And it takes a lot of time to gain this, if you're going to read yourself. The next one I'm going to say, it's about factor analysis. Also again, very deep. Okay. Now, this is fine. But the thing is, from here, this is about explaining the variance, right? In 1,300 dimensional world. Can we do something similar, explaining associations in 1,300 dimensional space? Is the question clear to you? There's a difference. Explaining the variance versus explaining the associations. Correlations. Associations are correlations, very commonly known as correlations. So from here, I can get a correlation matrix. No big deal. You divide this column by its standard deviation and its row by the same standard deviation. right? So this one becomes the first correlation coefficient. And it so happens its standard deviation, rows and same standard deviation, column same standard deviation times standard deviation is variance. So what happens here? 1, because it's an association between its own variable, right? So from here I can go to correlation matrix, right? Usually we do it in R. Okay? R. The notation is R. Correlation matrix notation is R. Okay. So what we are saying is R11, R12. How many? Somebody? 1,300, comma 1,300, right? Like that. R21, R22. Now this should be R1 1,300, right? 1, comma 1,000. This is R2, right? This is R 1,300, comma 1. Get it done. R 1,300, comma. There is something about R 1,300, 1,300. What is that value? 1. Is it the only place you get 1 in this matrix? All diagonals will be same. 1, 1, 1. That's beautiful, right? That's good. You have to remember this because your interviewer might confuse you. You know, you will give you a correlate matrix with some value in diagonal, more different from one. You have to say, oh no, wait, what's going on? Why did you put? Oh, it's a typo. Okay, right? You have to be very clear. As far as I'm concerned, you are the master, and you go for interview. Right? Okay, so this is your correlate. Do you know how you get from here? Every row, every column with the corresponding standard deviation. So if you do 10th row, 15th column, what are the standard deviation you will? Which standard deviation you will use for the row? Which standard deviation you will use for the column? You'll get a star. She's getting too many stars. Somebody have to try. Arun and you, please. Soumya, Rajesh, Gautam, Vinesh. For 10th row, that means I'm talking about R 10, comma 15. Which standard deviation you will divide for the row? Which standard deviation you will divide for the column? Please. Tack, quick.
Row 10.
10th standard deviation, you will whole row you divide. 10th column, 15th column, you divide the 15th standard deviation, right? Then that position will become the R 10, comma. So if you from here you can direct. Right? Of course, with R you just ask instead of variance box VAR, you call QR. R will do it, but you don't know how to interpret. The question is, there could be relationships. This is what the R matrix tells you, the association among the variables, right? Can we use the association among the variables to reduce the dimension? And what is that kind of, what does that really mean? What kind of dimension reduction we are talking about? That is called the factor analysis. You were saying something? You were saying something.
Where is the highly correlated?
Highly correlated variable, you can bring them together to a lower dimension, right? Right? That's the way everybody got it. So in other words, those variables that are highly correlated, why do I have to have two different variables? I can make it one. And interestingly, highly correlation doesn't have to be only pairwise correlation. It could be partial correlation. There are deeper issues out there. But the point is, like there I said rotation, here also some kind of a rotation is happening here, but it's very abstract. I don't want to go into the deep mathematics of it, but you can understand that, right? So among multiple variables, there will be correlations, right? And if there are among multiple variables, they are all highly correlated and they are all connected. That's why they are all highly correlated. Why should I have to keep multiple variables? I can just keep one variable. That's the kind of question they are talking about. Okay, so it is in the association hidden. Below in the association, there is common hidden variable is there. That is what we are trying to pull out. But correlation by definition is linearity. Linearity has something very interesting, right? The whole thing, whole life is mostly about linearity. all sophisticated things we can talk non-linear systems, this and that, but in the end it's really linear. Okay, piecewise linear and so on. Okay, so the point is, how do we can we get that kind of intelligence from data? Through association, but it has a different implications. It has a different implication. What it says is inside hidden variables are there. In the variance covariance measure, there is no hidden variables. We are talking about the original variables we are using. But here we are talking about there is some hidden variable, that's why they are correlated. Make sense? That is called factor analysis. Okay? So we work with R matrix. Actually, inside is what is happening. We are working R matrix. They're not the case. But of course, from here only we get this. This one we get from data matrix. Only 3 matrices you work in real life. Data matrix, variance covariance, R matrix. It's an interview question. Now, what is the difference between factor analysis and PCA? Man, they will ask like this. Okay, PCA is just dimension reduction in the original variables. Factor analysis is variable, hidden variable, latent variable, identification of latent variables, hidden variables in the original data set. Both are coming from the original data set, but it's about variance covariance matrix. Okay, and here is the association relationship. Here is the hidden. This is not hidden. Here is just a rotation of the variables into a new variable. But here, do you understand what I'm saying? In PCA, you are getting a new variable. There also the PCA, the epsilon 1, epsilon 2 are the new dimensions. But it is in the observed space. But in factor analysis, it is not in the observed space. It's underlying, there is some correlation. Some variable is causing these associations among these variables. And we pull out that variable. That's a latent variable. That is a factor. When we say factors, factor is used in many ways. Here in this case, it's factor analysis means that hidden latent variable analysis. You can say factor is equal to latent variable. In this case, that's what it is. Factor is equal to latent variable. That means hidden variable. Because of that hidden variable, only the associations are coming up in the data. Everybody get it? Okay. So let's review the places data one more time. Then we will be fine. We have few other examples also, and I think Supriya has been talking to you also with other examples. So if you just keep on thinking about it, you'll be fine. See, anything is once you know, oh, is that all? But until you know, oh my goodness, there's too many things are here, this and that. That's how you'll feel. But you want to get to the place where you know what it is, you know how to measure, how to interpret, and how to use the codes. That's all the problem. Okay. So let's review that one more time. I called it a one more time because I did it once, but I want to do it one more time. And on top of it, I also mentioned that this is decomposition, decomposition. This is also decomposition involved here, but it's so deep. I will show some mathematics of it, but the point is, there's also a decomposition where we cut this, to a certain number of variables. Again, you'll have a street plot, all those things. Okay, everything is same. In the original data matrix, I'll connect it to now. What is this recommendation analysis, data analysis, recommendation systems? In that, we are talking about directly working with data. Here, working with the variance covariance. Here, working with the correlation matrix. In the case of recommendation engine, we directly work with the data. So that's where we use singular value decomposition. Okay, and you are the only one who said that the dimension is 1300, minimum of the rows and columns, right? In singular value, that's what will happen because your data matrix is like that. But here it is your data. In a way, it is a calculated data matrix, right? It is symmetric. It's very easy to say that I'm going without there. There it's a little bit difficult, but you have to remember that it's a minimum of the dimension, the rows and columns. Here also the same thing. The thing is, so I even went and touched on recommender system right now. We'll come back to that in more detail. We'll go through codes to calculate and interpret all those things. But the same ideas are applicable, and it is 3 different types of data structures that gives rise to 3 different analytical types. Data matrix directly gives you recommender systems, data matrix into variance covariance, and talking about spread. Okay, talking about the spread in the data is giving you PCA. Talking about associations in the data gives you the FA. The recommender system, you will see, you will see one of the solutions is the SVD solution, that is singular value definition solution. People do, intuitively they thought some method, collaborative method, this and that, but you will see SVD is the most sophisticated. Okay. All these things, decomposition systems are the most sophisticated by the nature of the mathematics built into it. Okay. Do I make sense to you, all of you? So let's go to that, review that one more time. With this again, I hope I can capture your imagination. And then next session will be about cluster analysis. The next 1.5 hours. So let's go to this one. There are other methods also, the correspondence analysis, we want to review that too. We will do that, correspondence analysis. Okay, so what did I say? Places. Okay. There are, my notes as you can read it, huh? You can read, huh? Oh, if I do whole screen, it's better, huh? Oh, இதெல்லாம் வேற bother பண்ணுதா? Sorry about that. It's better that I see this, Okay, I will make it better. It takes time, yeah. It's better, right? The thing is, what I want to do is, I can search it. This is for me input, because I didn't know this screen like this. Okay, so I got to search. Something is happening. Where do I search? I need to search show taskbar. I'm looking.
The screen has a dual screen. Duplicate display. Screen it has duplicate display.
Oh, duplicate display. Huh? The command for the duplicate display. Control P. Control P is print. I think control. Let me see function. Here, I see it here. Duplicate. Okay. Yeah. Which one? We are talking about duplicate, right? That is this one is. But it will go out. I think it will go away now. But my point is this: I'm trying to search the almanac data. Where is it? That's what I'm trying to do. One moment. Okay, but it's not. It's not full screen. That's the problem. I don't want you guys to be struggling with my search process. You know what I'm saying? The thing is, escape. Okay, that's fine. So let me see. Oh, give me a moment, okay? Now I want to search the Control F. Maybe it will come here automatically, and I have to do Control F. No, it's not. Okay. Okay. So my point is now let's go to the data, right? There is USA arrest data. These are all, by the nature of massive applications of these ideas in USA, you get most of the time USA data set and this and that. But I'm very happy to talk to you if you bring your own data. Okay, no problem. But the thing is, what I want to show you is the places rated harmony, because I introduced that to you. This one was not there. I think you said online. They changed it, but let me check one more time whether I'm able to locate that. If not, no worries. I think we can always find. The new is the new link is given. It's not that they made it not available for others, but they changed the link. The new online, something like that they have it. So it doesn't work. No worries. But the point is, the data I basically sourced it from there, but it's available all over. So the point here is that I think okay. So let me go to R. I have to go to R. I can't just work this, right? R Studio. There is also USRS data. All kinds of data are there now. So in the lab, that's what we do. Network connection. Someone joined? Nobody is here. Nobody joined. Okay. What is it? You want places written automatically? Yeah, we are talking about. It's not here. Where do I have it? Places written. Okay, so never mind. You know what? I'm going to start a new one. We'll do new. It's okay. New file, new all markdown. We always do all markdown, right? You're all your daily life should be only used all markdown. Places. Right. Okay. I don't want these things. Okay. And we'll save it as places rated almanac. You want to go into PA2 personal. Okay, PA2. Okay. All right. So here, remember the package was 2, right? Library 2. You remember? I don't know. You remember? You remember? Okay. TOURR. Control I have to put it in a chunk. Then only control will work. Chunk is this way. I can enter the chunk now. Now it will work. Error in 2. TOURR than a library says. Library. Okay. All right, it's good. Now that has data. Okay, that's the whole idea is that get the data back. What do you do usually? First, I think it's all data places. It's all right. Now I can do get places. So there is okay. How many variables are there? There are 14 columns are there. 14 variables are there. How many rows are there? We don't know yet. We got to find that out. That's very easy to do. Use dimension. Dimension places. So you're all doing PA2 already. Actually, if you are given a job, you will start working, right? PA1, right? PA1 problems you can solve, right? Yeah, you must solve. You have to be confident. If you are not confident, I will lose confidence. P1 we did. We spent a lot of time. Please. In another 2-3 weeks, you will be done with PA2. You should be able to do this thing. In fact, you should be in a position to teach others also. All right. So how many rows are there data? 329. 329 rows are there. 14 columns are there. There is no dependent variable here, right? That's a problem, right? But what are those 14 columns? That's what this one is, right? It tells you you can go, this one, if you do this way, it takes you to the next collection of variables, right? Climate is first, these are all indices, right? Housing cost, cost actually, this kind of healthcare, some kind of index, I don't know. Okay, so you can read what they mean as a places data harmonic. If you go to that data set, it will explain. I think we have actually places data harmonic dictionary also I gave you. Where is there? It is there in the places data harmonic dictionary. Okay, so you know the definition of all those variables, right? Okay, so let's go ahead and do the work. So, so you want to see, this is the data matrix, right? So you want to do control chunk, maybe use the same chunk, maybe. No, let's do another chunk. So let's calculate variance of places. We don't want all of them. We want only places. 0 places, comma. Does this make sense to you, folks? 0 to 9. Does it make sense to you? What does this mean? I'm selecting all rows are 9 columns only, right? These are very basic. Everybody has to be very clear about this, right? So, and I take that part as the data matrix one. That is a partial data matrix, and then I calculate variance covariance matrix for them. So, how many? What is the dimension of the variance covariance matrix? 9 by 9 by 9, right? So it's a variance covariance, right? So if I do this, then it's going to come out as basically variance covariance, right? Control. So it has already created. Look at this one. So well, I don't want. Okay. See, if I use the same line, I will get 2 outputs. Otherwise, I'll get only 1 output. So I do car. Same thing. So instead of doing all the time again, I can store these partial results and then create. So it has done both the variance covariance matrix and the correlation matrix here. See, look at this one. This variable arts is highly correlated with healthcare. See this one? Anything above 3 is, I will say, high correlation. In my way of thinking, in my world, most of the time that's what I find. About 0.3, 0.4, I'll consider as correlation. So arts is correlated with health, but there is no correlation between transportation and climate. I think it makes sense. Because transportation has to be good. It doesn't matter whether it is hot or cold. It is a state policy people, it's overall I'm saying state policy investment people make because they, especially in USA states which are progressive, they have a commitment to give good transportation system to people. So nothing to do with climate. It predominantly depends on political systems, progressiveness. Political system. So the progressiveness can be all over the country. Okay, so you can see that economics is negatively correlated with climate, of course. Usually for some strange reason it happens. Colder climates are very productive in US. Okay, except but even San Francisco it's cold in my opinion. It's not like Texas is productive only because it has oil. And then they are investing a lot of money in infrastructure, and they give a lot of tax credit because they cannot get any industry there any other way. In California, you don't have to give tax credit; people will go there because it's the community that helps the organizations to grow. Easy to establish entrepreneurial organizations and grow. But in Texas, it's so hot. You don't want to go there. Actually, I don't know. You may not realize that, you want warm, right? You want a warm weather. I like warm weather, but if it's too hot, it's beyond limits. After a while, you don't want it. But Chennai is okay. I think Bangalore is better, right? That's the reason. You see, here is a great example. I think that's the reason, part of the reason why people love Bangalore. Weather is more moderate, a little bit more moderate. Here on a summer day, when it is too much humidity, oh, it kills. I don't know whether you understand what I'm saying. I have experienced it. After going to US only, I experienced it. Because when you live here daily, you don't realize that. You are suffering, but you don't realize that. When on summer day, when the humidity with the heat is what actually is the hard one, right? So kind of all over sticks to you, right? The bottom bits, right? Sticks to you. And it's kind of piercing in the heat. I don't know whether you felt it. Anyone felt?
Bangalore can feel it.
No, in Bangalore you do. You feel like that. Even in summer.
Bangalore, the most
In summer, scorching it. Not here. No, what I am saying is, so yeah, sweating will cool you down. But the thing is, sweating will allow only if the humidity is not there. If the humidity is there, the humid water sticks to your body skin, especially if you don't wear full sleeves and all, you will actually have, and you cannot perspire. That's what you're saying. If you perspire, then it will cool your body. So
You're more like pulling the heat inside.
Inside, that is the reason I think it's burning inside, right? But you do feel it. I have felt it. And then you come into the AC. It feels nice. Net. Hot weather is not really good for productive. I've given you a story about it, why it doesn't work. The climate condition matters for productivity. And productivity matters in economics. That's what I'm saying. So, but point is, you got to various comments, you can get very easy. Everybody gets very, but when you get it, you have a lot more meaning about the various comments. Not about all you are thinking about PCA, various matrix. Now, and here is the association of the correlation matrix. Now, anyway, what is that we want to do? We want to do just very easy. You can do print comp or print principal analysis. There are a lot of packages you can use. Okay, but you can also do your own. You can actually create your own package, right? It's all about variance decomposition, the eigenvalue decomposition, and how you are going to interpret the eigenvectors, eigenvalues. That's the end of the story. Really, you can write your own R package. Am I making sense to you? Do you feel confident? Yes. Okay. Thank you, Solring. Before. Okay. Very confident. And you cannot make a mistake. Okay. If you make a mistake, you correct. That's it. I was saying, because you don't know Tangi means hesitantly saying. Don't say hesitantly. Say it. If it's not correct, we'll correct it. All right. So, but we don't want to do, our own package now. We don't have time. We don't want to do. You have to spend time in terms of the accuracy of it. Make sure that the results are out, and we'll validate. You have to do testing and so on. But people do get excited. They start doing it. That's what they. Once I taught him the neural network. He started writing his own neural network programs. I told him, please don't do that because we spend time, to correct, to verify, validate, and then they release the package. That is the reason why you should follow package. But he's so excited. He always writes his own neural network. It may happen to you also. But don't get too excited because you want to use other people's work time. No, you optimize your time and utilize other people's. They spend time to validate, test, make sure that there are no errors and so on. Okay. All right, so we will use print. I think I have. Actually, in this one, I actually developed the eigenvalue decomposition. Look at this one. You see this one? Proving that EVD, eigenvalue decomposition, does its job as promised. And then I put list to find all the objects in the basket of the outputs created by PRCOM. PRCOM and whatever I do will be same. That's what I was trying to do here to show you, to convince you. And then I am plotting the the most important dimensions. You see this one, G plot? and that is called also called biplot. That is two-dimensional plot. Bi means two. Two-dimensional plot, but the two-dimension, the axes are principal components, not the original variables. Am I making sense? The principal components are new variables. New variables. So we can do that also. So there is a PR comp, probably it is done in the previous page. Let me see. Look at this one, US ARS data, but let's go back to our data. We talked about only this one, right? This is about image analysis. Predictive modeling of big data with limited memory. R tutorial and case study and its okay, so what happened on our places data almanac? Not oh, இதுல இருக்கு zip file இருக்கு. Okay, we got இல்ல you're talking about, I know what you're saying. File. Huh?
Factor mine are the factor mine are packages on the PA file.
Oh, இங்க இருக்க மேலையா? இங்கயா?
PA2 notes assignment, not RMD.
Oh, RM file இல்ல zip file RMD file இதுல இருக்குன்றா. Yes, okay, fine. Can I open it now? It should work, right? So you are aware of the places rendered almanac. You can understand the commands. You can understand the PC1, PC2. Everything is aware. So listen to me very carefully. I'm going to ask a question. Sir, I'm going to ask a question. So let's say place rendered almanac is 9 variable we are taking, right? 0 to 9, 10 variable we are taking. 10 variable, 0 to 9, right? 0 to 9, 10 variables you are taking. So it's because it is 10 variable, I'm using as the base for understanding the places. Right? There are going to be maximum 10 dimensions. But let's say I take only 2 dimensions. Think about it very carefully. What we are saying is that the original variance covariance matrix with all the variables is explainable with only 2 dimensions in the new variable system, right? The rotation space. All right. So if I have 2 principal components and I use those PC1, PC2 only, I'm saying still it is the variance covariance of the original data. Variance covariance of original data. It is not exactly same because it is not mathematically rest of them are 0. It's approximately same. Correct? Everybody, right? It's approximately. So, but the point is, this is variance covariance matrix explained by these 2 dimensions only, right? Variance covariance matrix is explained by these 2 dimensions only. Can we get back the original data from the reduced dimensions? Is the question clear to you?
Yes.
Is the question is clear to you? If the question is clear to you, we should be able to get back to our original data. Okay? And that is what, given a principal component, get back your data. I mean, sometimes this question comes, can we get back to the data, original data? But it's not going to be exactly the same, remember that. Okay, it is going to be only approximately the same. It will be same if I use all the components, all the principal components. Everybody is good on that, right? So these are all the exercises that we have to do part of the analysis. So let's see whether we can do. So here she mentioned that there is reference to that. Oh yes, PA places rated. USRS are there, and then rate is also there. Yeah, factor minor use. We use factor minor to get all these results. Let's run it. Can we do? There are different ways to get different packages are there. Okay, we can try all the things and see why they are same or different. They cannot be different. Okay, factor minor does also for factor analysis and PCA. So it is there. So can we do that? These are all. So PL is defined as the places, a small matrix of data, and I want to get the library there. Factor minor. Okay. Now with that I can define PP has all the PCAs. Everybody. So let's see just what is this PP refers to. Just I can print a PP. When I call this way, it is going to print, right? No, it does. PP is not defined. Why? It says this is done, right? Yes or no? Is there an error? Oh, there is an error. Why? Let me see. Could not find the function PCA because this didn't run, I guess. Library didn't work. So install is not there. Oh, maybe it's not there. That's why it is factor. Okay. Let me install and then I should be able to recall on this. I want everybody to show energy. Okay, everybody should be coming out, talking, asking questions, challenging, making mistakes too. That's okay, right? This is a class. You are supposed to make mistakes here, not in your interview. All right. So now let me run a library. I have to call the library, right? I can do that there. I think I have to do it just because I don't know whether library local library is that name. Okay, library. You can put with and without. Doesn't matter. It should work. Factor minor. Now it was okay. Okay, that's good. Still there. Okay. So PP is done. Let me recall. Oh my goodness, there are a lot of objects out there, right? For that data, this gives me the eigenvalues. So let's call this. How do I call that one? PP dollar eigen, right? So these are the eigenvalues. Everybody gets it? It not only gives eigenvalue, it gives the cumulative eigenvalue variance. It's a first dimension is 3.4 divided by the sum of all the eigenvalue sums, right? Which is 37%. Everybody, does that make sense to you? 3.41 is 37% of the sum of all the eigenvalues. That's what it is. That tells you how much variance is explained. Percentage of variance explained is very important concept. So if people might ask you, okay, I got first dimension, how do I know its importance value? Oh, you just take the first eigenvalue, divide by sum of the eigenvalue. That is what your percentage explained by the first dimension. Okay. So like that, you got this one. This package, because it's written in the package, it gives you all these things very nicely, calculated for you. So you can see this one. Cumulatively, it should be 100, right here. Makes sense? Makes sense. So there are a lot of things are there. So what is this results of the report? So we have to read the package to understand what these things mean. But you can actually kind of understand, many things quickly. But there are some things that I want to explain in detail. So if you put PP dollar var, it should be the same as what we did before, right? But it is for standardized variables, I think. That's why it is becoming small. You know what I'm saying? It was not this small before. It was huge numbers, right? But it's all centered or centered and standardized. Okay. Centered and standardized. Usually centered. So if it is standardized, it becomes oh, okay. Oh, yeah, a car is given. Yeah, it automatically gives car. Is that what you're saying? Yes. This one? And that's what I'm saying. This one. Correlation. Dollar correlation. Is that what you're talking? That is this one. This one. Okay.
vectors, matrices. List of matrices.
So this is not, this is, remember, this is, we are talking in terms, when we say bar, it is not the variance covariance matrix. I want to be careful explaining it. It's not to the variance covariance matrix. It is the coordinates explaining the variance. It is the coordinates. When we say that it's a coordinates. These are the dimension one. These are the PC1, PC2, like that. Okay, but explaining the variance. But when we say car, we are not talking about correlation matrix here. It's the relationship between those PC1 and it is the relationship that is explained here. In this case, it is the same value. It looks like it is the same value. No, I mean the because it is centered and standardized, they will be same. Okay, it's not. It will not be different. So you can do the PCA for the correlation matrix also, using correlation matrix also. You can do PCA. Okay, but it's much more clearer, well-defined, well-answered. If you say it is about variance is explained is the PCA. The associations explained using hidden variables is your factor analysis. Take that way. See, the other thing is, these are all written by somebody, right? Like practitioners like us, and their own variations, interest, they will write it there. But the clarity, whether they will establish all the clarity exactly like what you have been looking for, understood, may not be there. In fact, that's part of the problem with the open source. This is the open source. In fact, that is the reason why, that's the reason, that's how SAS actually sells its product. They will say that, no, our product is validated by scores of doctorates with the common purpose of making sure that these are all correct. Nobody validates this. Somebody writes it, he will write a package, I write a package. I do it for my own understanding and for my own purpose. That may not be the most commonly needed purpose or most commonly explainable purpose, right? So you have to be a little bit careful about all. And having teaching you all, you might also be thinking, teaching you all about R and Python, that is an issue. With open source, that's an issue. But you don't have to be worried too much about it. You got to be cautious about it. That's the point. Okay, because the reason why I'm saying that all these things can mean some specific meaning. It may not mean what is most commonly understood. And then in that case, you have to be careful. You have to go and read the package, how they use it, and so on. Are you with me? Everybody with me? I'm trying to make you to be cautious. I'm not trying to scare you. Oh, if that is the case, what am I going to do? R is giving me this answer. He's saying now R, you have to be thinking about it. Well, that's a reality because these are all written by some practitioner for their purpose, the way they think and use the terminologies. Okay, am I making sense to all of you? Please be careful, huh? So we want to understand what this, the cosine 2 is. Cosine 2 is it's really another way of, it's not cosine 2, it's a cosine square. Okay, it's a kind of distance. Also correlation. That's the correlation can be calculated using cosine function. Okay, so that's why I'm saying you have to be a little bit careful. So let's go to the package. I'm going to go to the package factor minor R, right? Minor PCA example places. Yeah, I think I took it from here this time. So he has given more details in terms of what they mean and cosine 2, this and that. Okay. So the first one is about the sports example you were talking about, but I want to go to the Iris. But I think places recommending.
Places.
Oh no, I don't know where it is. Why it came out. Oh, 2. Yes.
No, the package is the
It's okay. I will search. Atomic. Yes. Let's spend some time on this trip. Let's spend some time to fix all this things. I'm working with you. Fact from my scripts and videos. Huh? Already? He's changing material. That's okay. We'll see. Places. Very alright. Are you published?
No, they are having a lot of students uploading various information.
This is not the place, but somewhere I don't know why it's places is missing, places missing. Places missing. So let's go to another example. It's okay that USRS is fine. I can get it.
Fancy was it?
I'll come to that. It's a different, See, I want to explain those 3 or 4 important terminologies. Okay, that's the only thing, only reason why I'm doing this.
Can you get to 10 minutes by the way?
Oh, 10 minutes is the time? 4 o'clock, right? Yeah. We started today. Yeah, yes, please. Go ahead. Good time for me.
It's a very nice one, but gets stuck there on the recording stop.
Oh, yes. Thank you.
Very good.
Uh, oh, it's still going.
Stop recording. That's okay.
Pause பண்ணிடுவோம்.
Long pause.
Yeah, long pause. So I want to take this as an example, quick review. There is places related almanac. I have already done it. Do you have the notes with you? Huh? Everybody? Lena, I will give you the codes later on. Okay. So the codes I wanted to try is now what is called the USARS. And then look at this one. PRCOM is the package function. Okay. The PRCOM is just calling USARS dataset name, scale true. I told you, right? You can scale it. You can, in fact, scaling is better because that way all variables have same unit of measurement. Right? If you scale means standardize it. Sometimes the centering means 2 means. That means you only subtract the mean. Scale means you are standardizing it. That means you are dividing by the standard deviation. Okay, so the moment you do this, PCA.dress has all the objects, and one of them is rotation. That's what your PCAs are. Rotation, you remember, you have to connect back. Rotation is same as PCA, it's same as the most dominant actions. So original variables are here, and then this is the PCA1, PCA2. There can only be maximum is if 4 variables are there, only 4 PCA can be there. We know that, right? So that's why there are only 4 of them out there. And then you can get each of the variables PCA resolution standard deviation. So it also gives us an. So why don't we do this? Let's do USARS of data. Data is available in the data set itself. Let me check. Oh, it is already there. The moment I think it's the base package has it. Okay, so let me go back to okay. See what there is. Like USARS, there is also USARS. Okay, but this so there are each of the state has 4 measurements. The percentage of murders 400,000. Okay, percentage of assaults 400,000. Percentage, not percentage, count of assaults. Okay. This is, I think it's all count. Let me do one thing. So you can also use this question mark this, then you have the description of this, the variables here. So here you can see numeric murder, this numeric assault. This is what urban population is percent urban population. This is percent. This is not percent. Sorry, I'll take back. Okay, this is actually the number of numerical murders. Okay, 400,000. Assaults is 400,000. Urban population is percentage of urban population to the whole population. And then the rape is the number of numeric rape arrests per 100,000. Okay. So there are 50 states are there. So what is the dimension? If you look at it, you can see there must be 50 rows and 4 columns, right? The technical speed. That's what it is. Yeah. All right. So what we are saying is that now you can find out. You just do the PRCOM as a function, right? To PRCOM as a function. Okay. So let's do this one. PRCOM. And I'm storing it under PCA.results. Okay. So you want to see what are the things it has? PCA.res. LS, if you do center, rotation, scale, standard deviation, X. Okay. We'll find out what this means. So places.
It says all type under the same function for places.
For you are talking about for this one here.
The same command.
எங்க போட்டுட்டு
அது நீங்க இதுக்கு பண்ணிட்டீங்க USARS பண்ணிட்டீங்களா places.
Oh, right. You mean PCA.res photo you did? And then type of what? You called in for type of what? Type mean data type, right? Data type. Yeah, data type is double means it's not double precision. Yeah, double precision. They call it that double precision. Right? Every computer science. It's called double means double precision. Yeah, that means it will have more decimals you can allow, right? Usually it's decimal. Memory allocation is also needed for that. Number of digits you can get more, which is basically, in my opinion, it is just whether it is a fraction or not. A fraction allowed or not. But I don't know why R takes it as double.
Basically, when it comes to data frame, it goes for bigger space memory allocation. If it is small variable you use, okay, when I don't say mention anything and I directly assign a number, it directly takes the smallest form, that is the integer. So that is only like 2 bytes or something. But when it's double, it goes the bigger one.
Yeah, and it is not it is not just integer. It is allowed to have type fraction or without fraction. Okay. All right, so let's just understand these terminologies, what they mean. So this is an issue, right? As I told you, with the open source, you have to be very careful what they define. You have to find out what they define. You can't just I know car means this, that's what it is, but car may mean something else. You should not deviate too much, but you never know. But even SAS also, that's why SAS publishes volumes of books, practice books. They publish volumes of because we want to make sure that the people, users understand these terminologies in the same way as the developer did it. So it's very important, okay? All right, so rotation basically means it gives you a PCAs, right? That's what we expected. There is no confusion here, right? The variables and then the PCAs. Remember, as many number of variables are there, you will get as many number of PCAs. But you can call in only certain fewer number of PCAs if you want. For example, I can say I don't want all of them. I want only the first 2 PCAs. Up and down, I'll just do like this, right? Taking the contribution of. So now, how much variance is explained by each of the PCAs? It is related to the lambdas, I agree. No, it is all same. But you can also actually calculate it too in terms of the in terms of actual variance. Right? Let's see what it means here. So we are naming it as PCA dot variance. Basically, we take the results. There is a result called SVD. See this one, SDV. So let's just print that one. What happens? PCA dot res dollar SDV, right? So first dimension. Standard deviation is this much, so we have to square it. Okay, so if I square 1.578, 57487, right? 8783. Let's see, 8783 square. That is the variance of the first principal component. First principal component explains this much variance, but this much variance is has to be explained only in relative to total variance. That's why that is where it makes better sense. Okay, so that's why you want to do this divided by, you can do PCA res dollar as there, right? Square. What will it give in English? What will you say? It's better to put like this, right? Because it's a summation. It will be a summation. Square, I think I have to use sum, I think. Otherwise it won't work, right? Because it's a vector otherwise. Am I making sense? Right? Otherwise it's a vector, right? So, yeah, now it's okay. Everybody? It will give you what? In English, what is it? What will it give? What will it say?
Percentage.
Yes, the percentage explained by the first principal component. Okay, of the total variance in the data. The total variance is each of the diagonal variances. That's another way. Trace is basically each of the diagonal variance. Each of the diagonal variance. Some of these. Okay. So it says 62% of the variance in the whole data is explained by one dimension here, one principal. Am I making sense? But if you want to just do the sum alone, the total variance is this much, 4 units. That's right. And then you want each of the, you can just do it as a vector calculation. It's now the total variance for each of the dimensions, not total, each of the dimensions variance. and they are all independent. That's why you are able to sum them, right? Each is a perpendicular, direction, right, in the rotated space also. Okay, now.
So this four is the trace.
4 is a trace. Yeah. You can actually call for a trace. There is a function called traces. PCA variance PCA dot. Somebody was saying PCA dot trace. You want to go from there?
Yeah.
No, that is it's not the, yeah, you have to, this is just a results, right? You have to take a specific component. It's an object, and it has many components in that. Which component we'll have to take? We'll have to think about that, right? But instead we can do this one. Let's see what variance of the data is doing actually. Just let's play with that a little bit, huh? Very innocently we'll see what happens. Variance, what is the data here? Here is the USARS. Everybody? Argument must be a function. Trace. A call to trace. This is about programming trace. It's not matrix related trace. Okay, no worries. Yeah, it's about trace is to call back what's going on with the error, debugging tool. But that is not the trace I'm talking about. Trace means the sum of the diagonal values. Okay. But that is given to you as that's what the sum of the PCA dot res dollar SDEV squared. That is what your trace is really. Okay. So, but that is a mathematical trace, matrices trace. So what is that one moment? We want to quickly explain all the other things. So that's what he did. He calls it as variance ratio, right? That makes sense. Now, this is very important. Two plots I'm going to show it to you. One is scree plot. This is called scree plot. Okay. Why it's called scree, I don't know. SCREE. Okay. But what it really means is the plotting the lambda values. So the one which stabilizes, you have to stop. So it looks like, relatively, see this visualization, mentally relative values you calculate. So relatively, it looks like you need 3 dimensions. Are you with me, everybody? Because I see there is some significant reduction from year to year, right? This is, I don't know, maybe this was 67% is what is 62%, right? So second one, if you want second one alone, can we do that one? What I'm talking? So it's easy. I don't have to type this value. I will say PCA .rs. See whether it makes sense to you. Huh? SDev. I'm going to say 2. Make sense? That means the second dimension is value, right? So if you are any confused, calculate this. It should come to the same value, 2.48. Oh wait, yeah, 6. Yeah, because I standardized. I kind of divided by sum. So the same as this one, 6.2, right? So for the second value alone, how much? It's very easy. Just change this now. It's 24%. Each of them together comes almost 80%, right? 80% of the variance is explained by 2 dimensions. Isn't it cool? I think it's very important. Those dimensions are very, very important. All right. Now, so let's go back to so you can plot this one. That's what he's doing here, and he's giving all kinds of circle this and that. So let's do that immediately here. Variance ratio is not found because I didn't define variance ratio that way. So variance ratio should be defined. Variance ratio is defined here. What is that? Variance ratio. I have to define that. Okay. Fine. This, then comes this ratio. We'll do the same. Everybody is following, right? These are all very simple R commands, you all know. And then let's plot that. There you go. So this is the script plot. Usually, it's very easy to explain why you stopped with 3 dimensions or 2 dimensions. And the other one is you can also do cumulative. It's the same thing. Either you can do non-cumulative, each dimension explained how much, or cumulatively how much as you increase the dimension is explained. Okay? Because you are going to stop by, when you stop by some dimension, you are actually using all the dimensions up to that. So that's why cumulative percentage is better, useful. So let's do the whatever we called PCA resolution, PCA.res dollar, what did we do? PCA.res dollar, this one, right? It's called rotation, right? Once you create the object, the word rotation is what is giving you the PCS. Okay? Remember that in the PR comp, people might use different terminologies, so be careful about it. In PR comp, PCAs are the rotation. Then, this is what the biplot is. It's called biplot, or it is called biplot. Yeah, sometimes. Yeah, it is biplot. That's most commonly used. Okay, so what we are doing here is we are taking the points, data points, original data points. We want to plot it with only 2 dimensions, the new rotated space. Am I making sense?
Yes.
So your first axis will be first principal component, second axis will be second principal components, and even if you have thousands of variables, for visualization becomes easier in 2 dimensions. We use only first two components. It may be explained only 30% or 20%, doesn't matter. So sometimes people do 3 dimensions, and that is the reason I introduced the visualization, 3-dimensional visualization in the first class for you. So here is the question I have. Do you think you can do a 3-dimensional plot, let's call it as a triplot? Do you think you can do triplot? Similar to biplot, but extend it to the 1 more dimension. Our yes. He says yes. Yes? Anybody else? Everybody says yes?
Yes, sir.
You can do it. If you do it, again, you will be the master, because in the interview, nobody will know or even talk about triplot, because biplot itself is, kind of, I would say, principal component, this and that and so on. Now you'll say, no, I can do even 3 things. And I can rotate it and show it to you. That's very cool. Right? Everybody can do? I can take the message? Yes? Can you do it and show it to her?
Yes.
3-dimensional. Do that and then also rotate and see. It's fascinating. And that is the reason why I introduced the visualization in the beginning. But you have to do with the PCAs, remember that. The axes are PCAs. So what does that mean to say? The original points taken in the PCA dimension. What does that mean to say? Where do you get those points? Is my question clear to you? My question clear to you, right? Original data points are there, but you are not going to plot the original data points. The PCA representation of the original points. So in a biplot, you see the PCA1, PCA2. Rows are the states, not the mode and the four classes of RS. Not 4 variables. You're talking about the states, 50 states. You take the 50 states, those are the original observation, representation of each of the states, but you are condensing it into 2 dimensions called the PCA1, PC2. That point you are going to put it in the PCA1 dimension, PC2 dimension. Am I making sense? We will do that pretty soon. Yeah, that is what this means here. Otherwise, why would it be so many points here? There are 50 states are there. Okay, the New Mexico, California, North Carolina, South Carolina, Virginia, all these things, Dakota, right? Maine, Maryland, all these things are states. Am I making sense to you? So that is what biplot means. It's not you are putting the murder and you can do that also. So it is good because you remember the number of variables is how many number of variables you have, how many number of PCS you are going to have. So it so happens only 4 variables are there. But what if you have 1,300 variables? You can still take the 1,300 variables into 2-dimensional biplot again. So biplots are both for the rows or columns. Am I making sense? You can do biplots for either one of them. Okay. So rows means the data points, columns is variable. Biplots can be done for each of them. So you at that level of detail you have to think about. And in fact, because of that, you can do triplots also. I mean, making sense. The triplot is my concept. Right? I'm trying to encourage you to think in your own words. Okay. Nobody talks about tripod. You don't have to talk about it, but you can, right? Because you know it, and it gives you more freedom to look at the data in a higher dimension. Because if you have the ability to rotate that, you can visualize. If you don't have ability, then three-dimensional points on a two-dimensional plot you cannot see, right? So, but I taught you on the visualization, three-dimensional rotation, all those things you can. It would be great if you can do that for not this problem, but for the places right now.
Yeah.
Is it a good exercise?
We tried that one.
Indian states done great.
Yeah, and it's we learned
that. We got another data set also about Indian states. Okay, so you might be wondering, this guy.
Crime rate will be exceeding numbers. Small numbers won't also.
I don't know about that, but the point is, you might be frustrated. This guy always talks about US data set. No, there are some data sets available nowadays of late. There are data sets available in India. So here is the command for that PCA rotation, right? PCA rest is equal to PCA rotation. It keeps saying the same thing. Why rotation? Really? Okay, fine. What is he doing? I don't know. Okay, byplot is it takes the results. The command automatically takes care of that. But it takes care of it only by the observations, not the variables. You can do for the variables, technically speaking. But the byplot is the command byplot automatically does this for you. Okay, PCA.res, that the results. From that result, if you give the results, it picks up specific objects to do this byplot automatically. And what I want to impress on you is this one. This is actually the PC1. It is not. Yeah, here it is. This is the PC1 direction. This is the PC2 direction. Okay. So what is the purpose of this? So in two dimension, you can visualize that they are all grouped, right? They are grouped. I mean, eventually, the idea is, all these variables are explainable. Interesting results we can pull out. That is the kind of idea here. So take a look at it. North Carolina, South Carolina, Mississippi, they all come in this direction, right? Let's take the 4 parts here, right? 4 parts are easy to. There is one part here. The high. What is this one? This is a PC1. What is PC1? Let's see. Wherever it is, maximum loading is happening. That is the most important criteria, right? So PC1 maximum loadings are happening. All of them are negative. It's reduction in murder, assault, urban population. That doesn't make sense to me because
it's not that highly correlated with reference.
In relation to other data points, I agree. But PC2 is positive here, highly loaded here, right? Okay, that's fine. On the positive direction PC2 comes as murder and assault PC2. Okay. On the negative direction, Inge come here. Yes, this is the opposite direction. PC1 is going in the opposite direction. But urban population and rape are negative on well, all of them are negative in the PC1. Here, the positive is the murder and assault in PC2, and these two are urban population rape is negative. Okay, so first let's take this PC1 direction. PC1 direction is all of them are reduced. It says like that in this way. Okay, this is the PC1 direction. Okay, now the calculated values are these are all still calculated values. Remember, okay, row wise, this is what it is. It's called X value. Okay, X value. So Alabama is PC1 this value. So now I have 2 points, right? PC1, PC1. I can plot it there. That is these are the points that are plotted here. So the point is, they have some groupings. That's what these groupings, 4. So I can put a line here. I can put a line here like a graph. So this is one kind of grouping. This kind of another kind of grouping. This another kind of grouping. This another kind of, right? So you can see these are all mostly Ohio Northwest. Okay. Ohio, Washington. Washington is this is the state. It's the West Coast actually, but it has some developed area plus kind of not the mainstream area. Connecticut, I won't consider as mainstream. Okay, it's just a developed area. California is a mainstream, state that is very uniquely positioned in this one. This is the positive PC1 here, positive PC2 here. Okay, positive PC1 here, positive PC2 here. But California value is what is the California value? I want to see here California here. Okay, there you go. That's why it is on both directions. Positive. That's why it is there. Okay. So this really means it's a high crime rate. That's what it means. So, California is because a huge population. Multiracial, huge population. So the Alaska, California is the maximum value here. In PC2 also, positive number. That's why in this corner it is here. Okay. On the other hand, Virginia will be negative both. You can see that. Now let's see. So here is Virginia. You can see negative minus 0.09 and minus 0.9. The question will be in your mind, so what is the benefit of this? The benefit of this is I can group them into four parts, right? Positive, 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 negative, negative, positive, negative, negative, right? So I can group them and then explain these behaviors, the crime behaviors in these states. Am I making sense to you? So let's do, that's a biplot, you can do triplot also, but in this case it's not a big deal because it's only 4 dimensions are there, right? 4 variables are there, 3, it's no big deal. But if you have 1300 variables, the dimension can be a little bit more useful to you, definitely, compared to 2-dimensional biplots. So everybody can explain what is meant by biplot, right, in an interview. And you can draw also. In fact, you can do triplot too. Everybody agrees they can do it. Okay. All right, that's basically it. That's all the PCA is. No big deal. Now, can we do similar things in factor analysis? Let's quickly. Okay. Oh, okay, fine. So the red arrow refers to the original variables, right? So you can see urban population is highly in this direction, okay? And rape cases are, in this direction, right? More rape cases, and reduced is this way. More assault is this way. More. These doesn't look like perpendicular to you, right? Because these are the original variables. PCA1, PC1, PC2 are perpendicular, but the original variable don't have to be perpendicular, right? So, so you want to interpret the biplot in terms of the original variables. That is what this says, in this direction mostly pointing out to. New Mexico, Maryland, that is true. Maryland is high crime area. DC, near DC. Near DC. It's very adjacent. Like Pondicherry, Chennai.
Norfolk, highly populated.
Which one?
Norfolk. But it's not.
Norfolk is not.
DC.
Oh, Norfolk. Well, yeah, it is in the north. No, it's north of Norfolk is north of Maryland. But this is not. That's a city. Not Maryland, I think. Maryland state, Norfolk. Navy area, right. It's a city, but this we are plotting only for the states. So here, it so happens Alaska also has, for the small population, the murder rate is high. That's where it is coming. Does that make sense to it? We need to put the plots, and then we need to connect it to the original variables. In what direction, which variables are dominating. You might wonder, still it is not perfect, information, right? It's never perfect. You have to make sense. That is the responsibility of the analyst. The manager will ask you, so okay, great, so tell me, Arun, what does this mean to me? So you can explain all this. Very confusing. That's where you say, no, it's not confusing. I can say very clearly California dominates in this direction, right? Right, where urban population is there, and it is a huge state with urban population. And then there is more rapes than murder, that sort of thing, because murder is in this direction, right? On the other hand, Maryland and it's not a highly urbanized area. It is actually a kind of semi-urban area. It's not an urban, it's not urban. Yeah, but actually they have more assaults there, and it is true, in urban in my Maryland area. So you can go back to see this data point. Let's go back and see the data points. Okay, how about that? Can we do that to convince ourselves? This is actually very interesting when you keep on digging into it. No, let's convince the data and look at the data ourselves. What is that we are talking about? US dollars, right? So let's talk about California here. Go back to California. See, look at this one: murder, assault, urban population 91%. That's why it is pointing out in that direction, right? And rape is 40. But if you compare that to Maryland, because we saw that nicely plotted there. If you look at Maryland, where is that? Maryland. Okay, let's compare Maryland with what I need to. Okay, I'll make it bigger here. So California versus Maryland, just to compare, right? So this is Maryland and this is California. So you can see that this is what, and the top one is murder, right? Murder this is bigger. Assault is also bigger, right? But the urban population is smaller, significantly.
27%,
and then 27% versus here 40. That's why rape directions are pointing to California on the in the California side it is there, but not in the Maryland side. So it is giving you a good sense of mathematically valid, quick answer to you. And it takes time to process statistical information. It's processing and communicating statistical information is not easy because it has an uncertainty, and you are explaining the uncertainty. It's a tough job. But I always also say, I don't remember, you remember that statistics is a science of uncertainty. So there is nothing called perfect answer, but it is the most likely answer. You can't beat that. Somebody else can say, no, this is the most likely. They cannot say that provision, that ability, you are attaining it because of statistical science. Okay, remember always, it's not a perfect, perfect statement. On mathematics can be perfect, but not statistics. In fact, it is not. It is a science of approximation. So you have to believe in that and communicate at the same level. Eventually, your boss will buy into it. He has no other choice. Okay, all right. I buy into it. But you guys make it very difficult for me. No. Oh, you want to go back to the graph? Okay. You want to? You are talking about down. Sorry. Oh, you mean the biplot? Okay. Yeah.
PCA one, how do you interpret PCA2 for Virginia?
Virginia. Okay. So let's see. Virginia here is in the middle, right? It's in the middle.
And there's another one also.
Kentucky, Arkansas. Oh, West Virginia. Oh, this one. Okay, West Virginia is correct. West Virginia and some other state. That's okay. But West Virginia, is that what you want to know? How to interpret? We want to know how many.
What are the crimes?
Okay, PC2 is PC2 is the second. If you take only this direction, you are talking about you take that point and interpret it, whether it is positive or negative. But if you combine this information, then you are talking about these 4 points, right? This is positive. This is positive negative. This is negative positive. This is negative. So let's take West Virginia. It's a great example, because that's one extreme case down, right? Compared to California, it's opposite in some sense, right? It's opposite direction. Do you buy that?
Yes.
So before even looking at it, because we know California information. Can we just reverse all the information, and that should be that will be coming in the data point. You will see that it's not highly urbanized. Okay, it will have less rates, right? Because California has high rates, right? That's what we saw. And in terms of in terms of other crimes also, it will be a much less murder and less assault. Overall, less crime compared to other states. That is predictively, intuitively, we are saying that. Let's see whether it works out. It should work out. That's what this PCA1, PCA2 is doing it for us mathematically, right? So let's go back to the data. So here is the data point. West Virginia. So look at this one. This is very low, right? Compared to California. This is 5.7. This is what is California? 9. Almost half, right? A little bit more than half, but the point is lower, significantly lower. This one is assault is 276, right? Oh my goodness, look at 81. That's why it's opposite. That's what I'm trying to say. And then 39, this one, urban population, right? This is 91, right? That's why it is totally opposite. It's a great example. See, when you take opposite, it's much easier to understand, I'm pretty sure. Right? And then rape is here 31, right? Not 31, sorry, 40. Let's see what happens here. Oh, 9. Make sense? That's how you have to see. Interpretation is very, very important, and there is no perfect interpretation, perfect statement. And you have to, it's your duty to convince your manager. That's where you become the leader and he becomes the listener. He can ask questions, but in the end, you are controlling the conversation. It's very, very important. If you lose a controlling conversation, you lost the game because he will push all his confusions. You have to be there with clarity. Got it, everybody? You have to talk very, confidently. Because there are only so many statements. You have to just manage those statements correctly. Seriously, when you get there, you will enjoy your job. And there will always be opportunity for you to learn. And you call us, talk to us. There are people here who can, we want you to succeed. Even after even if you are successful, just call us, talk to us. Hey, you know what? I found some very interesting problem. I never saw this before. I want to come and share with you. Please do. You want to listen to those stories too. But in the end, you have to. A leader is one who controls the conversation. Okay, that means you have to know. You have to know beyond doubt. And in a situation which is very uncertain, statistics is a science of uncertainty. What does that mean to say beyond doubt? So you know where to draw the line. But say, oh, don't worry about it. These are all useless stuff. You have to know when to say that. And they are looking up to you. When you go there, they are looking up to you. See, in data science, we do teach, in all over the world. Especially, I'm talking about US, right? The communication issues are there, very, very important. Data scientists, statisticians are not that popular only because they cannot talk like data scientists. That is the definition of data scientists. They can talk. They should talk. And I stress a lot in conversation talking and so on. Okay, so that's how you become, you'll be closer to CEO because you know how to interpret data, how to use data. Yes. Please keep in mind and get to that. Emotionally, you have to get there. That you are going to be the leading the conversation. You have to be prepared well. You have to have the right visuals. You have to have the right models, and go there with good interpretation, and so on. Thank you, Kogo. That's it. It will be joy. It will be fun. When you get there, it will be fun. The person who knows the data is the conversation leader, because you have proof. Others don't. They have only questions. Okay. I'm trying to impress on you so that you lead the conversation. It's really absolutely fun, and not only fun, you'll grow. When more and more problems you solve, you'll be sought after by the organization. Okay. Any questions? So you're all committed to talk, be the leader in conversation. And what is that you have to do to be the leader in conversation?
No.
Huh?
No.
No?
know about the data.
You want 1% at a time, please. No beyond doubt.
Beyond the doubt.
Oh, you should be above doubts. No doubts. Is that what you're saying? In the conversation, you should not have doubts. You should not be confusing others. Is that what you're saying? You should be providing answers. Okay, good. You should be providing the answer. You are the answer holder. They have to come to you to get the answer. You said something?
You know about the data.
You know about the data. You know the results. You know interpretations. You know the visuals. You have the visuals. You have the evidence. You know all the questions. You know all the answers. This is the best thing you can be, right?
Yes.
Nobody can know the answers like you are. That's a fun part of it. Also data science is about investigation. It's really, you're kind of trying to give, investigate and see the results, interpret the results, give the results. So it can be fun, but you have to do your work. You can't go there, with half results. You have to go beyond doubts. No doubts. No? Will you be able to do that?
Yes.
With enough material, you have enough material, right? Recently you are also learning Spark. You know how to do R, you know how to do Python, Spark. With Spark, you can do in-memory computation, hundreds of millions of records, right? Who can do that? You can do it. And Jeffrey, correct? Yes?
Yes.
Of course, yes. I believe in you. You have to believe in yourself. See, really, you can work with hundreds of millions of records, or you can work with only 10 observations. It's tough, but sometimes they will push you. Oh, we have only 20 observations. Can you solve the problem? There's only so much you can do. We will solve the problem. There's only so much you can do, right? But the point is, they will be seeking your service. They will be seeking your advice because you have the evidence, you have the investigative report. Nobody else has it. And it doesn't matter whether they have hundreds of millions of records or not. Spark is fun. We have been talking about yesterday. Because yesterday I was here and yesterday. From yesterday I've been talking about it. Spark is fun. It's great. 100 million records you can handle. Otherwise, R cannot handle 100 million. The Spark layer is there, right? Spark layer is equivalent to Python Spark, what PySpark is. Very straightforward. And with the limited 16 GB or 8 GB RAM, you can do hundreds of millions of records. Otherwise, you can't do. So you have all these tools. You have more tools. We are going to do cluster analysis. We're going to do recommendation engine. We're going to do machine learning, all those things. But I hope you are excited as much as I am. I'm excited for you. You have to be excited. Are you all getting ready for interviews? Yes? You have been talking about it? They should go. People get jobs with just one language, Python. People do get jobs with Python, R jobs, pure R jobs are there. And already PA1, already Spark, already RDBMS. What else? Oh, Boson. Boson,
Python still few of them are still starting.
Oh, you still start out. You're waiting?
Others around Python.
You have to take.
They are pure weekend.
Oh, it takes.
Spark को upload class.
Okay. But it is part of the course.
Yeah.
Yeah. So, enough jobs are there. Okay. So, all right, let's. Does that make sense, West Virginia? It makes sense, right? It's the opposite. That's what it is. But it's showing it in 2 dimensions. It's even the 4-dimensional data, it's showing it in 2 dimensions. Correct? And it can happen even if you have 100 dimensions. In 2 dimensions, you can capture the same spirit. It's the opposite of that one, or it is dominant in this axis, but less dominant in the other axis. Things like that. Any other question on that one? We enjoy so much, we spend a lot of time here. All right, that's it, right? So given the data, you can do all these things. Given the data, if you're doing PCA, take your byproduct. to the meeting. And that byproduct, you have to put both the observation rows and the columns. These are columns. Reds are columns here. Okay, put both. Then it's easy to explain everything in one visual. All right. So let's do one quickly. One FCA. So we have done one, but let's do one more. We'll finish it. And then I want to get, so you all understood the singular value decomposition, the image analysis, right? Everybody understood with the reduced dimensions, you are able to still capture the essential nature of the image, huh? No, 3 20 out of 481 dimensions, 10 or 20 dimensions, but you get the structure of the flowers. Yeah. That's very important because I'm kind of trying to get SVD will come in various places because your image matrix is image data. So data, when it is data, it is SVD. If there is going matrix, it's eigenvalue system. Into a number, that RGB numbers. That is rasterizing. It's called rasterizing, and R has a raster function. So it converts the image into a rasterized data numbers. Rasterized data means a number between 0 and 255. The intensity of a R color, the red, intensity of green, intensity of blue, each of them is rated between 0 to 255, which is 256 shades of that color. 256 shades of red, 256 shades of blue, 256 shades of green. Yeah, RGB. These combinations is what determines a specific type of color, a pink, or intense pink, or parrot green. No, it's a parrot green, right? Kilipachi. All those things are, everything has a meaning, right? And those things, every meaning is captured in number. Talking about everything has to be converted to numbers and text. That's the only way you can analyze. And in fact, historically we used to do it only in numbers, but then now we got into the mode of how to analyze even words. So, but all data, whether it is, we were talking earlier, GIF, how do we compare the GIF? The GIF is a representative of some keyword, high intensity of that keyword or not. For example, if somebody is dancing now, that means happy, with a smiley face dancing, it's happy, right? You can capture that with a happy. This GIF, you don't have to capture the RGB there. This GIF means happy or not. Okay, now the whole GIF is captured into a word. Now, if I have, 200 people's selection of GIF, each GIF may have, range, positive to negative with a particular word representation, right? Each GIF has actually a word meaning there, right? So you convert that into a word and you analyze that. In the same way, you convert an image into a number. So eventually, that's how we can do the analysis. Any other question? Okay, so I told you I will show one example of a flower, and then we will move on. Okay, factor analysis. So there are a lot of examples you can do. Oh God, so many examples. There are books. There are a lot of examples are there. Even internet, a lot of examples are there. Here's an example. Okay, so this example is about analysis of. Oh yeah, no, not actually. Okay, we'll do. There are some, we want to put some links, rearrange them, and so we'll give it to you at the end. Is that okay? At the end of the class, just in 1 or 2 weeks. Yeah, next week we will finish. On my side, I'll finish, and she'll spend some time on lab side and building.
So you are available
I'm here scheduled to be going back on 27. So I'll finish this, and hopefully I'll start machine learning also. If it is possible, I'll start building. Otherwise, I'll start machine learning from there. Yeah, I think so. Yes. No, it's not. So here is an example of what is called personality and cognition in psychology. It's commonly used in psychology because in psychology, it's very hard to measure whatever they say, like depression, they'll say. It's very hard to measure. So there are underlying factors that is causing depression. So what they will do is they'll collect data on the underlying factors, thinking that it will explain the depression in this case, right? Or happiness or intelligent. Intelligent, there is some underlying factors is what is giving rise to intelligence. It's not this intelligent variable. Am I making sense? So, so we construct a data collection approach where we collect data on various factors, and then we see what is called confirmatory factor analysis. What we do is confirmatory factor analysis. Now we confirm whether this exists or not. This relationship, these variables explain the intelligence or not. Okay, so explain that means the intelligence has the hidden factors. We are trying to measure the hidden factors and then collect data. Sometimes we do that way. Sometimes we collect data and then try to find out the hidden factors. That is exploratory. Okay, confirmatory means we try to confirm whether these are the factors. Exploratory means we have data, we will explore what are the hidden factors. There are two different approaches. But I teach you mostly about exploratory. Okay, confirmatory is next stage. You do all this well, you'll come to that and you will appreciate also. So, but the point is, what we are saying is it's getting scary, ugly, but I hope you'll accept the symbols. And what we are saying is that these are the observations. I think I explained that with the scores, right? In the previous example, I talked about scores, right? Mathematics, finance, and policy, or something like that. Three scores we explained. Remember that? Yes? No? So, what we are saying, these are the scores, right? These are the scores in P factors, not 3. In the previous example, I explained 3. I don't know if you remember. Do you remember? 3. No, you were not there. Oh, yeah. Okay. So who was here? Mathematics, finance, policy. Do you remember? Mathematics, finance, or econ policy. Yeah, management, finance, marketing, policy, right? Finance, marketing, policy. Three subjects, 5 scores. 5 people score. We analyze, right? I analyze, but it can be number of scores could be P factors, not just 3 or 4. It can be 10, 20, 100. It can be different, right? So this is the structure. What we are saying is that look very carefully. Please don't get threatened here. But I think that linearity is foundations is what I'm trying to impress on you. It's linear. Do you understand? This is how linear functions are written, right? V1, that is a constant. Always a linear expression would have a constant. Plus a weight factor, that is lambda 1. It's a weight. And then eta, that's called eta I1. Now, because a person has this, ith person has P scores, right? Like there he had 3 scores in the previous example. 4 person has 5 persons has 4. 1 person has 3 scores. Each person has 3 scores, right? Now this is the weight. This is the hidden variable score. This is what you observe. You get what I'm saying? This is what you observe score of an individual. But what we are saying is that this score has hidden factors. What are the hidden factors? The eta I1, eta I2, eta Ik, eta IM. M hidden factors are there. Well, listen very carefully. Huh? We don't know the weights. We don't know the hidden factors. We don't know the constant numbers. So forget about it. We know only this. What we know is on the left hand side. We are identifying not only the weights, but also the factors, hidden factors. Looks strange, isn't it? There is nothing there, only one column. But that column we observe for each of the person, right? And there are P tests, let's say psychological tests. There are P tests, and we will actually see an example. Isn't it strange that I have one column information, one vector of information, values for each person, and then from that I'm trying to pull out hidden factors. Something is too naughty here. I mean, it just doesn't make sense, right? That is the beauty of mathematics. What we are saying is that those hidden factors have linear relationships among them. That's only one constraint. That linearity simplifies. Linearity means what? Always a weighted factor plus weighted factor plus weighted factor you got. That is what linearity is. Okay. Weights refers tells you the level of importance. The higher the weight, the more important. Linearity means weighted sum. Okay, and the weights are telling you the level of importance. But it pulls out both. See, in regression, it is only pulling out the weights. You know the original variables. In the regression, you know the original variable. But here, we don't know the original hidden variable. We are pulling out the hidden variable. We are also pulling out its importance. You see how complicated these guys think, the mathematicians, statisticians think. Somehow they did that mathematics, it works. So this is the structure we are imposing that it has to work out to get us the answer. So this is the structure. We agree this is the structure of the structure implied in the factor analysis, because this is the starting point of factor analysis, mathematical structure for starting the factor analysis. So far so good, everybody with me? It looks ugly, but you have to just understand in English everything. Now, so this is intercepts. I said that V's are intercept we like, right? VJs are intercept. These are called factor loading. The weights are factor loading. Please write it down. Weights are basically called factor loadings. And then etas are the factor values, right? These are the factors that we are trying to pull out and understand. We want to extract this into our system and interpret them. Everybody? Okay. And finally, what we are saying, there is a fair, linear relationship, but with an error. There is nothing called perfect, right? We are saying the YA is the Y1, all first variable for each of the person has this structure with some error. Everybody? Okay, there is always some going to be error because it's all randomly influenced operations, right? Fine. So this is where it gets more bothersome, but don't worry about it. You buy into what I say, you'll be fine. So can I write this into your matrix form? Remember, all of them, the etas are all common, right? Lambdas are all varying. The whole matrix is lambda. Lambda can be taken out as a matrix, and the etas is a vector. So lambda eta can I write like this? Matrix times the vector. That is what this one is. You see this one? Now, listen more carefully. One more jump. Okay. So what I'm saying is that each of the variable, there are p variables are there, right? We measure p variables. We measure p variable. The p variable is structured like this. From this we want to estimate lambda. This is a lambda, the uppercase lambda, right? Uppercase lambda. Lambda, eta. We want to estimate those things. Lambdas are estimated. Etas are also estimated. In regression, we don't estimate the x variables. Only the weights we estimate. But here we estimate both. So it's something very strange, but it's all beautiful mathematics. Okay, we'll come to that. So far so good. So this is a structure we are actually implying when we talk about factor analysis. Everybody gets it? Good. Now I'm explaining it. V is the vector of intercepts. Lambda, capital lambda is the matrix of loadings, factor loadings. Capital psi, capital psi is the matrix of factor variances and covariances. It is not written here, it's coming later. Okay, and then theta, this is the capital uppercase theta is the matrix of residual variances and covariances. Now, how do you use it? No big deal. You take the variance covariance of this one, right side, right? And the left side, variance covariance of y in left side is the variance covariance. This expression, this goes away, constant will go away, variance covariance, cancel 0. So this is lambda, this is the variance covariance of eta is what psi we said here, right? So this variance covariance of this will become like this. Everybody so far so good? And then the variance covariance of this. Everybody's good? And that's what this psi is. So we are still trying to explain the variances in the observed values of y's, y1, y2, yp. And that is because of the structure we have like this. Basically, we are trying to explain. When we explain this, we are explaining this. Yes? When we explain on the left side, we are actually trying to do the explanation on the right side. Now, given that structure, very deeply we are going. So the factor structures is basically correlations between items and factors. That's what this lambda star psi means. Okay, because you remember that's what we have, we have come out from here. Okay, so so in essence, two-factor model. Okay, so simplified it to two now. Two-factor model. The big whatever P, all those things, I made it into 6 variables. P is 6, and then number of factor is only 2. Everybody gets it? So I can write the same thing here, whatever I have written it here, into that form, whatever I've written here. Okay, this I write it in the following. Everybody, do you agree with me? I'm just simplifying it. You could have said, why didn't you start? Why you could have started with the simplification and go there? Yes, I could have done it, but it's the same thing. Now, look at this one. This is 0. This is 0 here. There are values here, values here. What it means is it doesn't have to be exactly 0. It can be a small value, right? That's what we mean. So what we are saying, the first 3 variables are dominated by the factor 1. Second 3 variables are dominated by factor 2. That's what this means, right? In written form. Everybody's good? Okay. So when you estimate it through a process of some mathematical process, basically what we are saying, we are trying to explain sigma, which is same as saying explaining this part. And when we say we're explaining this part, we are basically estimating lambdas and so on. So if these values become, then we are saying the factor 1, basically explains. So I have created out of six measurements, I used only 2 factors to explain those 6 measurements. Do you get it? How we get into the process of explanation, reduction and explanation. We reduce the 6-dimensional measurement into 2-dimensional, explain about hidden factor measurement. Everybody is good? That's what we are trying to do here, okay? So, and we are going through this process here, basically explaining this is same as explaining this, that means explaining this. Okay, now let's do one more step. So what we are saying is that, I said exploratory and confirmatory, right? But we'll do only exploratory. Confirmatory means you have the structure, you want to அந்த ஜெனரேஷன் பா கால் ஷூலாம் படுதுன்னா அவ்வளோதான் அப்புறம் தூக்கம் வராது. He doesn't understand. I mean, this anything, any notebook, books and all.
Books, Bhagwan.
Bhagwan, yes.
उस कैटेगरी में है ऐसा बोल रहे हैं 100%.
Whoa, I have to learn Hindi from you. Okay, good, cool. So it was lying on me. Near my leg, I said, if I mistake it touches, then I cannot sleep. I grew up like that. Old generation. All right. So here is an example. Let's continue to work on this. Here is an example. There are so many different tests. There are 4 tests here already. Visual perception. Okay. It's intelligence tests we are talking about, right? We'll come to that. I'll come back, revisit again. There are 17 tests actually. This is 1, 2, 3, 4, 5 is general information. Okay. In each sentence below, you have 4 choices. For example, let's review this one. If I have this, what is next? You know this kind of thing, right? So this is the next, right? So visual perception test, there are 4 tests here, right? And then general information. Pumpkins grow on bushes, trees, vines, and shrubs. Where will you put it, right? Pumpkins grow on bushes, trees. It doesn't grow on trees. It doesn't grow on bushes. It doesn't grow on shrubs. It's a vine. It goes down, right? Coral comes from reefs, mines, trees, and tusks. So it gives this tests about your ability in words usage ability, right? But there are actually there is general information test and test 5. It's just explanation of some sample test. This is visual perception. This is general information. Object numbering matching. Okay, object to apple is matched with 29. Then you have to recall after, maybe immediately or afterwards. They'll close this one and then ask you to remember something. Object number, relationship. And then so they have how many tests are there? 3: visual, cubes, paper, lozenges, general, paragraph, sentence. So many tests are there, right? How many? 3, 6, 9, 10, 13, 16, 19 tests are there. More than that, huh? No. Yeah, 19 tests are there. Right, everybody? Sentence, word C. Do I have word C? Yes, here. So Here somebody is administered 19, the P is 19 here, right? And this is the correlation matrix. Everybody gets it? Every person has 19 tests, and then I have let's say 200 people tested in a school system. So I have 200 people, so I tested each of them tested with 19 tests, and using that I can carry it variance covariance measure as well as correlation measure, right? The question is, are these things basically representing same thing? Some of them will probably means the same thing, but we end up testing all these things because we don't know what is the right test to use. We keep putting lots and lots of tests, right? Kids are poor kids. At the young age, they have to go through these tests, 19 tests. It's a lot of work also involved, right? In calculating and so on. So eventually the question is now, explore and see whether we can reduce the dimension of the number of tests. And because they all have a relationship, the hidden relationship, and just concentrate on the hidden relationship, and that hidden relationship should mean something useful for the testing purposes. These are the problems. Everybody gets it? So this is the correlation matrix we get. So basically, you do the factor analysis, you see where the factors are dominating. That's the end of the story. Everybody gets it? Okay. So we have done the sample correlation, and then we do the estimation, and here the mathematics, all those things. Don't worry about it now that you know something. Let's calculate the factors. Oh, we also do the scree plot here. You see this one? 19 dimension, 19 correlate, 19 eigenvalues. And then there are basically 3 eigenvalues we need. The moment it stabilizes, you don't have to do anymore. There is a jump here between this 4th to 5th, but I don't know, that could be an issue or error, we don't know. It should be systematic smooth, okay? This can, it's a higher value, but the change is nothing. So there is some jump is happening. We can analyze more, go into the details of the data and understand how to remove all those things. It's an issue of the designing the tests. So, all right, all these things are telling you some contents and all those things, that's fine. But where is the factor loading? Here it is. This is, these are the factor loadings. Do you see what I'm saying? But don't forget about these titles here. That title we will come out with. Okay, that comes afterwards. You look at the factor loading and then, oh, okay, you know what? This says visual, cube, paper, lozenges. So this talks about memory, spatial relationship. Do you see what this kid can, for the kids who have higher loading, see, you remember, for every kid, we can go back and calculate these factor loadings. Because I have the factor loadings calculated, using this model, I can predict each kid. Am I making sense? It's all useful in the prediction eventually. So, a kid who is scoring high in visual cubes and paper and lozenges, but not scoring in paragraph, sentence, word C and word M, means to me that he is very good in spatial and memory, but not good in verbal. Am I making sense? This is how they conclude. So I have reduced the huge dimension data. Dimension could be in both ways, on the observation side as well as on the variable side. So in this case, we are reducing on the variable side. So these things are when going together, high scoring, that's what I mean, high loading, they are all going together. So that basically means spatial memory. These are all high loading work. And let's see what is this. This addition, code, counting. Oh, this is about numeracy, speed, right? Because addition, code, counting is coming there. They call it as speed. And this makes verbal, right? Sense. Verbal intelligence. This is speed. This is memory and spatial and memory. Well, there is more in spatial memory also. Word or, number or, recall. This is the recall. Okay. On the memory and memory recall, this one. This is number F again, figure W and so on. Continue to go, well, this is spatial memory. Oh, you can also separate further out. This is if you have 3 dimensions. If you have 4 dimensions, the spatial and memories are separating out. Do you see what I'm saying? It depends on how many dimensions you use, right? So when I used only 3 factor, it combines both memory and spatial in one column, one dimension. So far so good. So you can do every one of you can do. Given a data, you can do all these things. And these names you are giving, remember. Am I making sense to you?
Yes, sir.
This is you as an analyst will be giving these names. So that's basically factor analysis. You got a scree plot also here. You can ask for that. and you understand the loadings, factor loadings, tells you what kind of variable it is hidden. So what we are saying here is the hidden variable is spatial, and these are basically combining information from visual cues, paper, and lozenges. This one is memory, and these are basically combining this word recall, number recall, object recall, and figure writing. I think figure writing, figure W, figure writing. Yeah, you have to recall and write. Likewise, if I do 5, it further separates out. Verbal, memory, speed is coming out separately also. So that is what, that's how you use data collection process. Do you understand how the data collection is done for factor analysis? Do you understand that part? How the data is collected in factor analysis? Everybody understands that? Recall how the test were, we are talking about P test, and this is 19 tests for 200 kids, I said.
Exams 17 tests.
So everybody is given 17 tests, and then we score, and that is what they. And that score you use it to figure out the factor. It makes sense to you. Right? But on the other hand, how is it done in the case of PCA? How the data is collected in the PCA? It's just basically variables and then observations variables. Right? It could be places rated on, right? This place is rated on 7 categories. This movie is rated on 10 categories. Okay? Rated or scored or given some number, somewhere. So you have to think about the data generation process, under what condition what is used, and then use the algorithmic method, interpret it, and present it. And be the conversation leader. You're all committed, right? You'll be the conversation leader.
Yes.
That's it. It is fun.
So for the hidden variables, why
it can be, you can put a square and all. Foundations are linear, always. Just starting point. If you want to put, you can put square and all, but eventually you remember, non-linearity doesn't mean you, just because you add a squared variable. Non-linearity, because linearity in parameter, if it is parameters are linear, doesn't matter. You can put sin x. Your parameter is weighted sin x means linear. So your linearity means weighted in parameters. Linearity means the parameter is linear, not the variable. The variable, if you want, you can use a complex nonlinear variable. That is one fundamental important definition. You all have to remember what is meant by linearity. Linearity in parameters. That means weights are linear. Okay. If the weights are kind of exponential of lambda to the power 5, something like that, that's complex. Most of the problems are linear. Life is not that complicated. I'm not telling you, I'm saying in general, life is not that complicated. It's actually, if you use the right tools, that is very simple. A lot of problems we can solve. People would like to do, researchers, they would like to do, I'm going to do non-linear factor analysis. Yeah, it's all research. I can do good stuff. It's good stuff, good things, fine, get a PhD, go home, undo linearity. Eventually, that's what happens. You will all learn, this is a famous joke, you'll all learn all kinds of mathematics, all kinds of methods. Eventually, you will do normal regression and linear logistic regression. Our insurance problem, finally, we did SVM, this and that, random or everything. I should not discourage you. It's not about discouragement. Eventually, logistic regression was doing very nicely. In fact, in the interpretation, the logistic regression won everything else compared to. Right? But there are some places I worry about is that it's most of the time it's of the number of observations. That's what the means. In fact, recently I read an article that even to do neural networks, it's not about in neural networks there is a problem in fine tuning. Okay, your batch size, the atom parameters, the adaptive numbers, all those, the convergence speed, all those. The data, the amount of data you get will win all over this. So it comes down to the data. Data is king means that's what the issue, that is the issue. Algorithms are not that king. That's only queen. There's nothing wrong with that. Queens are a lot of fun. I know. So the point is, you can do sophisticated stuff. Sometimes it does help. I'm not saying it doesn't help. But it does something, beauty, simplicity, and power in standard stuff. Logistic regression still wins. I don't know. In the top, there are 151 algorithms are there, as well as I know. I read it in an in a journal article. There are only out of there only 5 matters. 150 all types of algorithms we are talking about. There are only 5 matters, right? What is the rate? We are talking about 120, 1/30th matters. 29 of them are useless. In practice, I'm saying, right? What are they? You are going to learn many of them, like random forest. Logistic regression, one of them, that's my point. And it's only about classification issue, right? Logistic regression is one. Random forest. Boosting. Average neural network. Not neural network, average neural network. There is an issue there. That's the point. And then SPM. These are the only 5 things. In the end, these are in the practice again and again. So, why did the other 29 people did 29 times actually? It's not 29 people, right? For every one, you have 29 additional algorithms on there, right? 5 algorithms, 150 algorithms versus 150 algorithms. So, why did they do? Well, we are humans. We try different methods. We take pride. We apply. Sometimes small incremental wins are there. But practice is I don't know that I used to tell in your class. Practice is different from academic learning. Practice is always the winner because your boss is the ultimate decision maker, not whether you did SVM or not. For him, did you make convincing answer? Give him convincing answer. Right? That is what is called practice. You may be the boss yourself, that's a different, but the point is there's something that makes a cut, says, no, don't do this, do this. That is called practice, right? Practice is more powerful than academic training. In the end, we are instructionally giving you academic training to you, all those things. I don't know whether you enjoy this conversation. I like to talk these things. But these are all important. This is the kind of binding factors, what I'm talking about, right? So practice is very important. The knowledge you have in practice means really practical. That's what it's called practice. You have become practical. You can learn all kinds of things. You can do great stuff. Talking about nonlinear effectiveness, practical, all these things. Practice matters. So a practitioner is a very practical person. Your boss is a practitioner. You may not be that practitioner, but he will make you to be a practitioner. Eventually, you will become a boss one day, right? That's what it means. I gave a long answer to your question. I don't know if you appreciate it or not. Yeah, we can do all those things, but this solves the problem. Any other question? There are a lot of other examples you can do. A lot of internet examples. We will give you some more additional links for you. But you understand what the problem is in each of the cases, right? So what I'm going to do is today, I will do, in the rest of the time I will do. I want to finish, because I would like to finish it this week. During the weekday, anybody can, all of you can come one session.
2 people cannot make it. 3 people cannot make it.
Say, okay, fine, next Saturday we will finish this from my side, okay? Tomorrow I'm going to teach. So tomorrow I'll finish. First session I'll finish. I don't know. Maybe first session I'll finish recommendation engine. Second session, but I'll give half of cluster analysis. Meaning you still have to do recommendation engine. Redo the same example. There are two examples of it. One is movie, the other one is jokes, right? I usually ask the lab people to do the jokes. I do the movies. You can use the same code.
Ask some other.
Yes, that's also fine. So I will have one more session in addition to tomorrow's 2 session, which is more than my commitment, but because otherwise I don't have time. I have to finish cluster analysis is huge. Very important practical solution.
Favorite question in it.
Yeah, favorite question, very important. Okay, cluster analysis I'll do next week. Tomorrow I'll do recommendations. Okay. I like it. I like it. Any questions? 3 hours you can tolerate, right? 4 hours? Okay. How long you can sit it? I want to take a. Okay. How many of you can sit? I want to get this answer. How many of you can sit out of the 3 hours? 1? Yes. No. 1.
Only 1 more hour.
1 more. Okay, you can say such partial answers also. 1 more hour. How many? 3, 4, 5. How many? 1 hour is okay. 1 hour. You are ready. You are prepared. Come prepared. அதுதான் நடுவில் இதெல்லாம் distract பண்றாங்க. I'm distracting you in this and that. I give my own opinions. But as you age, you will get opinions. Maybe it's a problem. But sometimes people like you if you have opinions, strong opinions. In USA, it's very valuable because they think that no, you cannot be strong opinionated unless you really know. I don't know whether it's true or not, but they respect if you have your own strong opinion. He has his own strong opinion.
Yeah.
He will say outright like nothing you can convince him. He is the opposite. This is what it is. It is black, no, it is white.
How he got re-elected?
Not re-elected, elected. The first time, the first time. He might get re-elected. He might get re-elected. This year is ending. The 4th year.
People are saying he come back.
He might come back. See, extremes are always before, I don't know. It's a time cycle.
They want to get refurbished, go through the mess like Brexit. They're replacing.
They will come back finally. Anyway, so 1 hour each of you. That's good news. I thought you guys wanted. I don't know. I think the lab shoes are we are very lucky. Supriya's taking the lab work. Very enthusiastic. I really appreciate it. We have people like Supriya, very engaging, very involved with your learning process and so on. Any questions today? So you can do. We basically did again and again. PCA we did it. Now we are doing it. But then I hope sometimes you have to drill. Like again and again you have to think about it too. That's the only way it gets written. But when you go out, you are the masters. You can explain to people, your boss, your co-workers, and if they try to confuse you, you can say, look, no, don't, I will explain everything, stop. Right? That's the attitude you have. At that level of confidence, you got. Good. Thank you very much, everyone. I have fun speaking with you. As I said, I may not, after 3 months, okay? So this is the best time. Let's use our time. Learn Not so many things are there. See, if you see all these things, there's some common things are there. Okay? And if you learn those common things, you are the master. It takes 2 years in colleges, I don't know why. But I wasn't part of that college system. 2 years, MSc 2 years. I had to struggle through my life. You will also do, you will go through some struggles, but it's okay. As long as you're committed, you're fine. Commitment is very, very important. And there are enough jobs for life in this area. Data science, machine learning, AI. So much to do. So much to do. Are you ready? You are already working in this area? Data science, machine learning. Oh, you're already.
So not machine learning.
You have been working on projects. Good, that's good. So hopefully these things make sense to you much faster.
Yes, but the kind of work that I'm doing for them is in the area of sales and the order management, products, how they're having it, how they should do it, how they, what I do is, what are all the products that they have been ordered for the last 5 years.
Customers.
Customers. What products, which is selling most, when they can sell, whatever you are teaching here, I apply to it and then I am telling them, okay.
So you are using whatever you learn immediately. Oh, that's great.
That is my business.
Oh, I see. Oh. So you are able to utilize, make sense, and make decisions, good decisions.
Yes, I can say, okay, see, this one is not at all sold for you, but you have got so many complaints. If it is selling more, what are all the complaints you have got?
Oh.
How many you have replaced? Then to replace it for them, then you will ask. Yes, you see this is the way it should be done. That is how I'm able to help them. But not in this, like applying what exactly our analytics or our statistics. That thing I'm not able to do, but say, okay, this is how this are all the income average, which month went high, which month went low.
So on foundation basics you are using. The bottom you are basically using nowadays.
It is helpful.
So eventually I hope you will use PA1, PA2.
Hardly 10 people in that. So whatever data I have got, Excel, 3 years access.
That's what happens. Most of the time, you are advanced actually. 10 people in India sitting and trying to learn and apply these things. Even in USA, where it's supposed to be a very advanced, market system, right? It forces you to apply latest things, soon and get benefit out of it. 50% of the companies still don't use it. Data is in Excel. If the data is in Excel, there is only so much you can do, right? You have to get to the system, the practice of, a well-committed process, where you can get the answers faster, better. You have to get to graduate to a level of R, at least. Now, Python is still considered as sophisticated, but the point is that, okay, R is the next level, you have to graduate. But R can, unless you go into Spark.
Yeah, the process of preparing a proper data set.
That is the issue. Quality issues are there.
Open the Excel file, 100 to MB or something like that. They have told all the customers what products they ordered. I shouldn't do it in Excel, but to start with,
you have to process, you have to internalize, that initially takes a lot to that. That is okay, but once you get used to R, then you will realize, how good it is, easy. Graphics and all you can do so wonderfully. Anything you can do. You can design your own graphics in R. In fact, that's why I will say R is great compared to even Python. Python, people have to write, but you can create your own graphics. I'm talking Python packages you have to use, matplot.
But then the Google Analytics is also there.
That is marketing.
They take the data and store it. But whatever is, say, open source, we shouldn't say free, but open source or something like that, that's what I'm using. If I breach a certain limit, then they will acquire having so much of data. Google will come and
Big data pioneer, they are the ones who came in with that idea and they become the backbenchers and nobody appreciates them in the market. That's the sad part of it.
Well, they make money. Everybody appreciates.
But the interface is that you can have a tab in your hand and enter. That analytics
freedom to
being that you enter is really.
Their the whole world is runs on keywords, and they know how to do that. In fact, yeah. Hmm? Yeah, it is. It is. You know, yeah, it's amazing.
Everyone can go for looking people. Face scanning has become easy for them. They started with a sweet thing like you want to know something about something. Take a sketch, you can take a snap of it and Google pick. What is that? I forgot the software name. It will give you the details about it.
Google Images.
Yeah, you put the image and it will image search by images.
For a stalker, it's all the more
Image search by emoji.
No, for a stalker, it is so easy for, isn't it? That's what you know. So that way it has become wrong.
Yeah, you're waiting.
For me, it's
I took time for me to process. What did she say? Oh, yeah, you can do this.
someone actually
Did
got
into trouble.
That girl got into trouble.
That's what I'm saying.
Yeah.
That's the saga. Behind, okay. Gosh.
They come in the beach, they take a snap, I take a selfie, someone else they come in the pic.
Previously, there was Google Square.
Where?
Google Square.
Ah.
So you put the images, you give the key from the source, and whether it was in like Google Labs was that previously. Those are kind of Google Square.
And all by little steps like version of.
See, all these things are happening where they have billions of records. You know, the AI is made possible today. You have to think this is what I'm saying. AI is made possible because of the large amount of data, not because of any other reason. Not because we have become sophisticated in algorithm. We have already were algorithm sophisticated, but we cannot use the algorithm as much as in the in the olden days we couldn't use the algorithm as much as we can do now, because now we have all this Google data, Google, MSN, Yahoo, collected data is so much. It provides even the smallest area of prediction, where we have, you see, basically there are only so many variations in patterns, right? If I have, let's say, the variations cannot be more than a million. In any concept you take, practically speaking, right? And that if I have billion data, what does that mean? It's a million. So that means each of the millionth point has million data points. So prediction is going to be accurate. That's all to it. Nothing. The AI didn't change because of the algorithm developed or something new. We have become more smarter more. That's why the data becomes the king or queen. Doesn't matter. No, gender specific. It doesn't matter which house. House queen or king or yeah. So, but given that so much data that you will also be capturing, you may think that if you build your system correctly, you can capture a lot of data. You will capture data, and there is benefit doing that. But then you should be ready to analyze those things, right? That's why these things matter. But Google does it because of their job. They make money out of capturing data.
Now, information selling is the biggest money-making thing. Who has information? It's not just.
No, nobody wants to sell it. They want to collect. They want to create products out of it. Create products out of it.
And then going in paparazzi or all those people who are.
They used to do that. Now, free paparazzi. With keywords.
I mean, these are the things that you actually when you go for data science, these things are highlighted. And in hacking, it is more.
What was Google's answer for that?
Which one?
Hacking,
to come or
hacking stockers.
Zuckerberg got the first. See, Facebook got the biggest splash. They are the ones who created that.
Nice. You never know, probably that guy.
I'm very sure.
It's already happening. Right?
He's not in a good book. Yeah, he's in the black side of it.
But for some reason, I don't know. Zuckerberg is, for some reason, he's in more bad books than others.
Big time, big time. Because he linked everything. YouTube, Facebook, and WhatsApp. Everything he has linked.
The phone, images,
Bank,
preferences,
so everything just theater. That's the worst case.
He's a Fitbit e-bot. Google is buying it.
Google is good.
That's what I was about to say. I didn't say that. The reason why they're getting is that now search is going to be on Fitbit going forward.
It is very bad.
The moment I saw he got Fitbit, okay, he's going to use
Google.
Google. Yeah, for insurance. That's what it is.
Oh, that's
Next. Your heart rate itself is owing that information to him. He will improve the insurance bills.
In my Apple Watch,
Yeah. This information goes to them also.
but Apple is much better.
Much secure. Much secure. I thank Bill
I can
Gates for that.
actually show you that. It's amazing.
Yeah, you can set hard fall also.
Huh?
Hard fall.
Hard fall.
Which helps you to send a.
But I bought this latest version only because of that. But this is what it makes, right? I don't know, everybody can see. I can show it. I
Sir,
don't know.
recording off the
It's not.
Sir, the recording off the right?
It shows right hard. If I touch this, then it will start.
Yeah.
Yes.
This is ECG. So if there is a abnormal